In our previous lesson, Chapter 9, Section 3, Part 1, we looked at parabolas in standard form. So we're essentially spending 2 days looking at parabolas here. We're still addressing Standard 16 and including Standard 17, which is taking any conic section in general form, completing the square on it, transforming it to standard form, deciding whether it's circle, ellipse, parabola, hyperbola, and then finding out everything there is to know about that, including its graph. So let's continue then with our parabola. And a parabola in general form, and actually all conic sections in general form, look something starting out with ax squared plus by squared plus cx plus dy equals z plus z equals 0. So you want to make sure that everything is on one side first, 0 is on the other side. How can you tell whether it's a circle, parabola, ellipse, hyperbola? Well, we've said in previous lesson that a circle, a and b, would be the same number, same sign. Parabola, either a is 0 or b is 0. Translation, either x squared is missing or y squared is missing. If you have both x squared and y squared, you don't have a parabola. If you have one or the other, you do have a parabola. And the strategy here is to get the variable that's not squared by itself, and then go from there to convert it from general form to standard form. So if there's no y squared, you want to solve for y. If there's no x squared, you want to solve for x. So we can still have horizontal or vertical parabolas. So as we look at this, everything on one side, nothing on the other side, there's no y squared. Since there's no y squared, this must be a parabola. Now I know we just told you this, but on the test we won't. So it's good to practice. It's a parabola. And since there's no y squared, we're going to solve for y. So to do that, 4y is negative x squared minus 6x minus 5. And let's complete the square by taking the constant, moving it to the other side. And remember, in the process of completing the square, this coefficient of the square term had to be positive 1, which it's not. So let's factor out that negative 1, and we're left with x squared plus 6x. All right, to make this a perfect square trinomial inside the parentheses, we're going to do what I call the Texas two-step. So 6 divided by 2 is 3. 3 squared is 9, but be very careful. The 9 that we would like to put here is being distributed by a negative 1. So we really added negative 9 to the right side of the equal sign, and we must add negative 9 to the left side of the equal sign in order to keep the equation equivalent. So in this case, 5 plus negative 9 is negative 4. This perfect square trinomial factors as the square root of the first one, square root of the last one, sine of the middle one, quantity squared. Let's take that constant and bring it back over by adding 4 to both sides. And let's divide everything in sight by 4 to truly isolate y and get it by itself. And we have standard form. Y equals negative 1/4 x plus 3 quantity squared plus 1. So from there, we can find everything we know about parabolas: up, down, narrow, normal, wide, vertex, axis of symmetry, focus, directrix, and graph. And we're going to do that quickly since that was part of our previous lesson. Our most recent lesson was to deal with standard form. So since this is negative, it opens down. Absolute value of negative 1/4 is less than 1. It's wide. My vertex is negative 3. Opposite of the number in parentheses, positive 1. Axis of symmetry is inside the parentheses here. X equals negative 3. X equals the opposite of this number. Focus, we're going to add 1 over 4a to the y value, since this is a parabola that opens up or down. We're going to add that to 1. A is negative 1/4 again. We saw one like this before. 4 times negative 1/4 is negative 1. 1 divided by negative 1 is negative 1. 1 plus negative 1 is 0. So our focus is located at negative 3, 0. Directrix, remember, if our axis of symmetry is x equals, directrix is y equals. It's going to be the y value of the vertex minus 1 over 4 times a. So that's minus a negative 1, which is the same as adding 1, or y equals 2. Then to get ready for the graph, we'll make a chart of points. We'll select some x values. And our axis of symmetry is x equals -3. So we want to go to the left or to the right of -3. Going to the right gives us points like -2, -1, 0, +1, +2. So let's put those numbers in the equation, see what we get out. If we put in -2, we get 3/4. If we put in -1, plus 3 is 2, 2 squared is 4, 4 times -1/4 is -1, plus 1 is 0. If we put in 0, we get out -1 1/4. If we substitute in 1, we get out -3. And so we get the idea that in this particular problem, odd values of x get rid of the fractions. So let's start plotting the points, starting with, let's remind ourselves what the vertex was, -3, +1. So here's our vertex, -3, +1. Here's some points on the graph. We have the point -1, 0. We have the point +1, -3. We have the axis of symmetry, which is a vertical line going through the vertex. We're going to have the mirror images of the points we calculated. So there they are. Let's sketch in our parabola. Let's plot the focus, which if you recall was the point -3, 0. So from the origin, -3, 0. And then let's remind ourselves before we plot, the directrix is y equals 2. So if we plot y equals 2, there's the directrix, here's our focus, vertex, all the points on our parabola that opens down. Let's look at another one in general form and do the same process on it. So when everything is on one side and 0 is on the other side, looks like x squared is missing. So we want to solve for x. And if we're solving for x, this is a parabola that opens left or right. So let's take this constant, move it over by subtracting 25. We're going to complete the square here, make that a perfect square trinomial. We do have a coefficient of 1. So when we do the Texas two-step on 2, 2 divided by 2 is 1, 1 squared is 1. That 1 is not being distributed by anything in front of any parentheses, so we really add 1. We have 12x minus 24. This perfect square trinomial factors as the square root of the first one, square root of the last one, sine of the middle one, quantity squared. Let's get x by itself by adding 24 and dividing everything in sight by 12. So x is 1/12 y minus 1 quantity squared plus 24/12, which is 2. Now that we've moved it from general form into standard form, let's quickly go through everything there is that we need to know. Since this is positive, the parabola is going to open to the right. Absolute value of 1/12, this is less than 1, so it's wider than usual. Vertex, be careful. The number inside the parentheses here is with y. So the opposite of that is the y value of the vertex, the 2 being the x value of the vertex. Axis of symmetry is found inside the parentheses. Y equals the opposite of that number, so y equals 1. For the focus, we're going to add 1/4a to the x value since we need to move it left or right and not up or down. A is 1/12. 4 times 1/12 is a third. 1 divided by a third is the same as 1 times 3, which is 3. 2 plus 3 is 5. And that's pretty far away from the vertex. But as we said, the wider the parabola is going to be, the further the focus is from the vertex. The narrower it is, the closer they're going to be together. Directrix then, since my axis of symmetry was y equals, my directrix is x equals. It's going to be the x value minus 1/4 times a. And we've already established the fact that that was 3. And 2 minus 3 is going to be -1. So x equals -1 is my equation for my directrix. Let's make a chart of points. Remember again here that we're choosing numbers for y. What numbers to choose? Well, let's look at the axis of symmetry, y equals 1. We're either going to go above or below 1, depending on whichever you prefer. And those are going to be y values, like 2, 3, 4, 5, and 6. That's above 1. 2 gives us 2 1/12. not sure we really want to plot that. 3 gives us 2 1/3. 4 gives us 2 3/4. 5 is 3 3/3. 7 gives us 5. I gave up on 6. So it was another fraction. So let's look at our graph paper. Let's remember what our vertex was. 2, 1. Plot our vertex, 2, 1. Plot some points on my graph. So here's the point. Let's find out what that point is. So 1, 2, 3, 4, 5, 7. There's my point 5, 7, the only point that didn't have fractions in it. And then here's some other points that we have that do have some fractions in. So we've got the x value of 1, 2, 2 3/4, which has a y value of 4. And then we have 3 1/3, which has a y value of 5. So that gives us an idea of what one side of our parabola is going to look like. If we draw our axis of symmetry, we're going to look for their mirror images on the other side. Once we have those mirror images, we can connect the dots and make a nice little parabola. We can plot our focus, which recall that was the point 5, 1. So from the origin, right 5, up 1. And we can plot our directrix, which is the line x equals -1. Decided to do them in lovely lime green in this case. And we've got everything we needed to know about our parabola. And again, you can see that the focus is pretty far away from this vertex. So the wider, the smaller fraction this is, the absolute value of that, the smaller that is, the further these two are going to be apart. The larger that this is than 1, the closer those two are going to be together. So there's our second look at parabolas. This time we just added going from general form to standard form.